I hope everybody is able to hear us. My name is Natarajan. I will be presenting on the topic how to reduce cost of quality, digital transformation of quality using live QC tools. I hope you are able to see the slide on the screen. If you are unable to see it, please just send a chat. Let's get started. We started EGS India. I'm not going to go through the introduction to EGS. I'll go directly into the topic for short of time. And the most important thing when we look at in the cost of quality is, before we started, we'll just give you a small introduction about EGS. We started in 1993 after I returned from the US. I was working at Ford Motor Company, and then I returned and started EGS India, specifically to work in the area of design and development of new products and technologies in India. So we have been working with many customers in the last 33 years, and we developed the quality management system and launched it last year, specifically for the benefit of the Indian industry. So today's topic is going to be about the challenges in cost. Let's look at the analysis of costs and then the steps to reduce cost and benefits and summarize the whole thing. Now, the classification of costs. When we look at any cost, prevention is the first thing that comes to mind because prevention is better than cure. Under prevention, we have 4 different classifications that we look at. Primarily, the risk management part of it coming with the FMEA, the failure modes and effects analysis, followed by the control plan, and then training of the personnel, and then capability indices to study that and make sure that they are within the requirement goals that we have set forth. So that involves a certain amount of cost. The next one is the appraisal cost. Appraisal cost means inspection. It's not the salary appraisal, it's the appraisal on the system for quality with regard to inspection, testing, audits, calibration, MSA. These also cost money, right? In terms of effort, in terms of resources that we are putting together. These are the second classification of costs. The third one is the internal costs related to scrap, rework, sorting of components, especially if you get into a situation of selective assembly, and then downtime, and then retesting. These are areas where we can say that the cost would be affecting quite a bit on the internal side. Next, on the external side, we have the customer complaints. We have the component returns in terms of the return merchandise authorization, the warranty, and then the field failures. Now, if you look at the cost of poor quality in manufacturing industry, you will see that the percentage of the actual sales that goes towards the cost of poor quality is shown here. Now, remember, we are talking about cost of poor quality. Now, if you look at the different segments, this actually comes from Quality Magazine. You see the spread of the cost of poor quality, but there is an interesting take to it. This is based on what qualifiable measures that we have looked at. Are we really looking at the full picture? Is the sum total cost already available all the time? Well, it depends on which industry you look forward to. Many years ago, 20 years ago, there was a conference on ERP in which one of the companies from Germany presented in the US on how they were looking at costs, specifically across 21 plants worldwide. There were 7 costing engineers who were sitting and looking at the cost itself, running through the cost calculations on the server. I'm talking about 20 years ago for an American plant. 7 people were looking at and looking only at the cost engineering part of view. Now, if we are measuring all the aspects of cost and you are coming within 5%, you're okay. Maybe you're okay. If you reduce it to 3%, that's 2% of your profit. And it's bottom line profit, not top line. So when you look at all the different segmentations, you will see that a survey was conducted and people were looking at how do organizations track the cost of quality. Cost of quality, mind you, is not only the cost of poor quality, but also the cost of implementing preventive and early warning systems. Right. So over 50% of them say we track cost components only, such as scrap, rework, and inspection labor. Then as you see, 34.8% said we use a comprehensive COQ model. This comes from Lumafield cost of quality report this year. So you can see the wide disparity between the implementation of cost of quality in terms of a model versus bits and pieces picking up information from different parts and saying, this is probably what the cost of quality is. So the first thing that we need to do is develop a deterministic cost of quality model, set goals before we start looking at reduction in cost of quality. So the framework has to be there. So when we look at which components of the COQ are measured, 66% of them, or 87% of them said internal failures, because it is visible. I put in the beginning the tip of the iceberg, but there's a big iceberg at the bottom. We haven't looked at that yet. The comprehensive image of what is lying beneath the ocean comes only when we start mapping it. So the external failures, because customers are demanding replacements, we know that 82.4% of them said external failures. Supplier related quality costs, yes, because you give an RMA, you get a debit note, you do that. Prevention costs, see, it starts coming down because it's not taken as a part of cost. Appraisal cost, still lesser. So we are not really getting a total overall comprehensive picture of the cost of quality. Now, when we are setting goals, it's only half the picture. Which portion of the COQ is not being measured? You see that? 25 to 50% of the cost of quality is not being measured by over 40% of the respondents. They are well aware of it. They are looking at ways and means to reduce that because they do not know how big the iceberg is below the sea level. So this is exactly where digital transformation comes into picture. What are the barriers to measuring cost of quality accurately? Beautiful. Data is scattered, living in silos across teams and systems in disparate systems. A ERP, maybe an MES, maybe spreadsheets, maybe on MES PowerPoint presentations to your managements. In different areas, it is lying. So the next one is it is difficult to quantify certain costs. Why? Unless we attempted, we would not know. I famously asked one of the purchase officer in a company, are you looking at the lowest cost of the object that you are purchasing, or are you looking at the lowest price? He said, I don't have wherewithals to get the lowest cost. So in other words, when the supplier is dealing with lowest price, you are running the risk of higher cost of quality, not really lower cost of quality. That's the risk because we look at L1. Limited time or resources such as budget. So I want everything at the touch of a button. I'm asking ChatGPT, Claude, and all the other tools, AI questions they are able to deliver. Why is that I'm not able to get answers delivered for my quality requirements? Because we simply don't have the data to put in there. It is our business, our data, which we need to connect the dots to get the cost of quality measured and moving upward. We lack the right tools and systems, 42.5%. No clear cost of ownership of cost of quality. One of the famous questions that people ask is, who is the owner of the cost of quality? Quality as it is owned by everybody, not only the quality department. Similarly, the cost of quality is owned by every department, which is influencing the cost, which is influencing the quality. Every one of them is important. So it's a teamwork which delivers finally at the end of the day. I cannot obtain senior leadership buy-in for investing in these kinds of tools and technologies. These are commonplace barriers to cost of measurement of cost of quality accurately. So what is not being monitored cannot be measured or controlled. So if the quality cost needs to be controlled, first we need to understand where we need to find the needle in the haystack. How many needles are there in the haystack? And connect the dots. Same applies to quality COQ reduction. So if I want cost of quality to be reduced, first I need to know wherewithals of the data that are coming in to put this together. Now, let us look at a scenario. If I had a digital threading, if I had everything coming in, and if I am able to see at any point of time in a day or a week or a shift, I should be able to tell the cost of quality analysis. Put the computer to work like a slave to get the information what you want, to start connecting the dots. Tomorrow, if you are going to be ready with all the data for an on-premise AI implementation, you need at least 3 years of data to be in there for it to give you productive output from AI intelligence. So that digital framework has to come in. For that, one of the benefits of that is your instantaneous reports with regards to cost of quality. Now, if you look at the cost of quality analysis over here, you will see suddenly there is a spike in warranty claims in March because your customer sent you the RMA forms to be filled out because they wanted it to be on that year's balance sheet. They accumulated everything and you never saw it coming in March. You are busy invoicing your customer, not realizing how much RMA you are getting. You see how lethal it is? So when we start monitoring these data, these are all different aspects coming across different months. This information should come to you from the computer without anybody being involved. In other words, automatically. Only during the initial implementation, you require people to put this framework together. After that, the system is on autopilot. That's how you need to set up things. Some people say, can I not get this from my ERP system? ERP is only one portion of it. Is MSA a part of ERP? Is root cause analysis a part of ERP? Is audit cost a part of ERP? There are many questions are coming where ERP really does not serve the purpose. It's only a repository for data that is required. It is not for analysis of data. Yes, some ERP systems give quality management tools as a part of add-on because they didn't want to lose a customer. So the ERP guy gave you that. But is it a quality ERP? Is it a quality-driven ERP? We need to ponder and think there. So when you look at this, the overall cost of ownership, you look at the external failure costs, you look at the internal failure cost, you look at the prevention cost, and you look at the external failure cost as well. You will see a fine balance has to be established between all of these, and these are dynamically varying, mind you. So you need to have a platform where data comes in from different forms, could be spreadsheet, could be Excel, could be from your customer, could be from ERP, could be from operators on your line, inspectors on your line, could be customer feedback, so many different ways in which now the platform has to put the data together and serve you like a slave. When it does that, you will be able to get all these different kinds of charts, which helps you to interpret the data at any point of time during the day work hours in your organization so that you can make informed decisions at your level. If you look at the casting defects for a particular supplier, let us say you look at the Pareto, I want to look at the entire data inside. Now remember, I can do this inside Excel, but the data is sitting inside a silo called as an XLSX file. If you share it with other people on the email, or on a central repository on a network drive, people can open it. Oops, what if they edit it by accident and save it? Are you with me? So now when you look at the warranty analysis, what is working, what is not working, which part is really serving up the warranty cost? Now, if you look at all the, what is that, donut charts, you will see pretty much most of them are equal, right? That says the process is stable, not a single influencing coefficient is tipping the cart. Now you need to have equal contributors that says that the process is stable and the pie has to shrink. These are the two things we need to look at. Similarly, when you look at region-wise or cost-wise, the picture changes completely. Where to put my eggs? In which area should I concentrate to reduce my overall cost, the burden that is coming in? So another area is your supplier gives you a raw material. You go through an inward inspection. It costs you money to do inward inspection. You are taking all the stones from the rice and you are taking only the rice. The stones are being discarded, but you are putting the time together to discard the stones. Have you discarded all the stones, or they are going to get into the boiled rice and hit your upper teeth when you start eating? This comes in only with dynamic performance monitoring all over the place. Now we all know that the fishbone diagram is available, right? If you are using a furnace and if you are putting a casting together, the energy bill is a huge bill for you. We are always looking at OEE, right? So the energy bill is pretty high. Now on top of it, Europe is going to come up with the CBAM tax from the beginning of 2026 onwards. Already it has started living, depending on your carbon footprint. So now you know exactly what are all the causal indicators that are going to keep your spikes up with regard to your carbon footprint. You have a fishbone diagram for that. If I click on a particular causal indicator on the fishbone diagram, I should get the current data. Otherwise, of what use is the fishbone diagram? Now you look at this example. It's a casting defect analysis. I am putting together the entire thing and I am saying these are all the issues that I am getting. Now, are we monitoring each one of them? Is the operator skilled? Is it a low temperature problem? Is it an excess pouring into the mold problem? Is the ladle frequency an issue? Can I take the data and look at it immediately? Can I have a dashboard of all the causal indicators? From a fishbone, we always do a root cause analysis. In that we put a fishbone, right? Why can't we use the fishbone to de-risk the process and get the costs down? So in the reverse, the fishbone becomes the mainstay. Why? Because fishbone is a risk mitigator. Your FMEA is your risk mitigator. Your money lies there, not in the charts, but in looking at which charts are critical, which are really in the critical zone, especially with regard to the prioritization on your PFMEA. So when I look at the root cause analysis, for example, I look at a plastic part. I look at the root cause. I know exactly what the fishbone diagram with regard to the defects in plastics are. Am I monitoring them? Actively monitoring. Who is monitoring? What is the cascading effect of that monitor to bring the process back into centrality? The appraisal cost goes up a little bit incrementally, but your internal cost and the external costs just vanishes. The secret sauce for reducing the overall cost of quality is look at your risks, which are enumerated in your fishbone diagram. not as a part of a ritualistic process called as root cause analysis, but proactively as a part of cost of quality. If there's one thing I want you to take home today, it is that. And keep a mechanism for monitoring each and every one of them live on your system, putting a digital network together. I'll take this drop arm example. Drop arm is used typically in a steering system. You have a conical tapered hole on one side where the ball joint comes in on the left side. Then you have the spline section on the right side where your power steering unit sector shaft comes out, right? So it goes and gets mounted onto that. And then you have the lock washer and the lock nut. It's a simple component. Now, when I look at the drawing of that, this is not any customer's drawing. This is drawing only for representation purpose that we have put together based on, because we do a lot of product design and development at EGS. So you look at all the parameters which are sitting over there. Now you need to monitor all these parameters, not all the parameters. Then your cost goes up, appraisal cost goes up. Only those CTQs. And which are the CTQs? DFMEA should tell you, right? So let us say I am monitoring a few processes. I am monitoring the raw material chemistry because 9 out of 10 times it is the raw material which is the culprit. You give an input which is not a desirable characteristic input. You go through how much ever your beautiful process and you want a deterministic output. Are you going to get it? So at every point of time, you have to process monitoring has to be there. So the raw material to the billet temperature, to the die temperature, to the forging load, to the heat treatment, to the hardness, to the machining, to spline dimensions, and final inspection. Now remember, in every one of them, raw material chemistry, I need to use some equipment, spectrometer, destructive evaluation. So many different ways I have to do it. Am I calibrating those instruments? Are those equipments used actively under maintenance, and are they within the peak of their performance? Is the operator trained? All these questions people ask in audit. We supply what is called as evidence, and immediately the auditor puts a tick. We feel great about it. Audit does not bring money home. Your cost of quality brings your money home. It's money left on the table. Can I get an alert immediately as soon as calibration is wacko in my material analysis in chemistry? Absolutely, you should be able to get it. And the billet temperature, it keeps fluctuating. When was the last time you calibrated it? The furnace part of it. And then the die temperature. Die has suddenly cracked. Why? Was the die temperature being monitored? It prematurely failed as a result of during a lower duty cycle, but away from warranty. Just a few weeks after warranty, the die gave up, looked up in the sky and said, I have retired. That's your cost of poor quality, right? Who is billing for it? Your production is stopped. You have to get a replacement die. You have to actively monitor the die temperature. Not only monitor the die temperature, but also look at the trends so that you can predict it. That's exactly where AI will help you subsequently down the line. Then the forging loading, then the heat treatment process, so many things. In every one of them, we are measuring things. So the process we are going to use for creating this component has to be transparent to all the stakeholders. What do you mean by stakeholder? Everything is transparent. Inward inspection of billets. Okay, if I click on that, I should be able to get the information what I want. You should be able to see what are all the things there, and you see the inward inspection data is there. You pick it up in a couple of clicks. You should be able to get the entire data transformed into usable charts for your requirements, folks. How much time does it take for you to do this? This is live data that we are showing. your own data, if it were to be in your organization. Now, this gives you the information as to where actionable data is, an actionable form is coming, and you should be able to make sure that every information is available. For example, mechanical properties. Do I have the mechanical properties of this? Control charts are available, these different types of charts, the beautiful ones. What is the process capability? Oops, CPK is bad. CP is bad. Has the alert gone? Then I do a chemical analysis. I look at the results of that as well and see which supplier is giving residuals and issues, whom I should concentrate on. Then I look at, I want to reduce the amount of flash in my forging operation. So the input casting should be within certain weight, right? Otherwise they add up weight, you pay for it, you get flash. Now see, the process is not okay at your supplier side. Many outliers. So like that, every information which is sitting in your process, you should be in a position to take this information directly. The advantage of doing this is you will be able to get all these parameters the way you want it, getting tracked dynamically on dashboards, put it on the display systems in your office or in your manufacturing base, so that the operators can look at it and do the performance correction right there itself. In Tamil, it is called as Varumun Kapavan Arivali. The intelligent are the people who foresee the pitfall. So the benefits of this kind of an approach is reduction of scrap, elimination of rework, reduced sorting, reduced the final inspection burden. The traditional method is give a specification, you inspect, pass or fail. While here, the process data, SPC, trending, predicting, alerting, and then correcting. Everything is happening on autopilot. This is the advantage. Now, let us say we have a spline dimension given as for 25 plus or minus 0.5. And the current process mean is 0.05. CP is 1.67. CPK is gradually falling from 1.55 to 1.2. The parts will still be confirming 100%, but the system will tell the production team that it's deteriorating and the NC is about to happen, investigate. So that converts failure detection into failure prevention. It's an early warning system. You put your clothes on the clothesline and you have allowed it to dry. Suddenly it's going to start raining. Immediately before it starts raining, when it's cloudy, you start going and picking up the clothes, right? That's early warning system, right? In your system. Similarly, in your professional life. So current scenario is you have everything in silos. FMEA is sitting in one file. Control plan is sitting in another. SPC data somewhere else, mostly for audit purposes. And then NCR kappa somewhere else, compliance, it's all in different systems. When you put this to digitally in a threaded format, your FMEA risks controls looks at your control plan. They are tethered together. It is tethered together with your inspection and dynamic SPC. It is tethered together with the actual process performance, defect NCR, root cause, kappa, and then the FMEA update. It's a cyclical chain which keeps going as a part of the continuous process improvement that ISO 9000 mandates from 2015 onwards, with risk associated with it being captured. So and please understand, the chain is only as strong as the weakest link. If you do something in this list only for audit purposes, that is your weakest link. Audit is a byproduct. Any day we should be in a position to be audit ready. Now let us look at the characteristic diagram for a particular billet rejection. The same data what you saw, you are able to see the traceability at every point of the way using the heat code. right? When I get any data within out of control process, any process in any organization, if it is going through an out of control thing, then we should be in a position to bring it back into centrality. For that, how should I do it, sir? This is your fishbone diagram for it. So in this, you start monitoring every process. Comprehensively, everything will come into this. Unsuitable techniques for operation in processes. You put an NC, revise your process, put a checklist together, make sure it does not happen. Worn out equipment, maintenance not done, alert did not go through, put an alert, get it done. If it doesn't, then escalate it to the next level. Same with lack of maintenance. Same with temperature changes. Same with merging or mixing of batches. So many different aspects. Yeah, the reason why I am concentrating on the fishbone diagram is people typically look at it from an RCA point of view. Folks, that's old business. So any object, for example, this, what is that? I'm going to now show you on this drop arm. We will take you through how to connect the dots, so that early up in the process itself, you catch all the outliers before they start underperforming the entire, bringing the system down. So first you have the drawing, then you have the ballooning for inspection, then the process flow diagram, the PFMEA, the control plan, the SPC, and the alerts. Now watch this. I take the drawing, I put the ballooning on the drawing. I showed you the drawing earlier. Now the balloons are given on the drawing, right? Oops. Now the process number is coming on the right side. Hold on, let me highlight it. The process is coming on the right side, right there. For every one of the balloons, we are putting the process over there. Then the drawing information. The process has not been tied. The PFMEA has not been tied. The control plan is not yet done. The FAI is not there. We have only put the drawing information. Now the bill of characteristics, we have put it together directly from your balloon drawing. You get your BOC. After you get the BOC, the bill of process is coming in because you just entered that. Right? Now, everything is in the red on the right side. Did you notice that? Because we have not connected it to the rest of the things. When you connect it, then everything comes into with the dot. Process FMEA, process flow, control plan, and FAI. So none of them are connected. So 0% is overall compliance is 0%. Now you say, I am going to attach the process flow diagram to this. The moment you attach it, all the processes come over there. This is linking of the process. So the completed process flow diagram is sitting over here. This could be done independently and attached to this. Now the risks associated with the process. You take the PFMEA and you link line by line as well. You take each and every one of those processes. The operator number comes directly from what you gave here, right? It's all linked. And then you get your PFMEA with your SOD. Now you view the inspection reference for the PFMEA. You will be able to see what are all the inspection references that are coming over there, which is linked and which is not linked. Information comes right there itself. Next, the characteristic summary. Where are we now? 8 out of 8 in process FMEA, 8 out of 8 in process flow. So every one of them is mapped to a risk. So it's clearly done. So it is green. But the other two are yet to be started. Now you take your control plan. For each process that you enumerated earlier, automatically it has come here. And your control plan is now completed. This could be distributed to different people in the organization. Collaborative. Assign a task, give a time, deadline, and then put it together. Attach evidence for each and every one of the line. When you do it, all of them are now controlled. So 100% completely. You have done everything over here. You have allocated to individuals down the line who needs to inspect what, at what stage, who needs to calibrate what, at what stage. Everything has been given and the tasks have been given and the tasks are monitored. If it's not completed, immediately you get a raise alert. And when the process starts deteriorating or moving away from the mean, you start getting alerts for your 8 process control chart intelligence, right? You get that. So this becomes possible only when you tie all of them together as it is shown over here. So the paradigm shift is after you have taken all these things together and you have linked it, none of them slips through the fingers. You will be able to see the COPQ category of the data coming in. What is the total cost of quality? 1.35 crores. In that, for scrap, you can drill down and you can say what is the contributing Pareto for each one of them. For the forging, inside the scrap, you can say what is the reason for, what is the maximum contributor, die mismatch. For the die mismatch, what is the biggest thing? Die wear. You see that? Like that, you can go through at each and every one of them and put it and look at the key performance indicators on your system. So the summary is there is no slipping between fingers, no lack of visibility, no audit issues, no hidden cost of quality. Yes, it is a deterministic and a lower cost of quality because you have set the goals and you are monitoring it dynamically. That brings us to the end of this presentation on how to reduce cost of quality in the organization. The most important takeaway for you is look at all the costs. Assume that you are going to perform a root cause analysis because there has been a failure and come up with all the causal indicators and then start monitoring every one of them so that that does not occur. And then prioritize it according to your SOD. Now I leave the floor to any questions that people may have with regard to this presentation.